Hi, in section 4.1, we want to talk about the other applications in trigonometry. And the first of them is the law of sine. Before we learn about the law of sine, we want to know what is an oblique triangle. An oblique triangle is a triangle that does not contain any right angle. So in previous chapters, we learned about the properties of the right triangle. Now in this section, we want to talk about non-right triangle, which is called oblique triangles. An oblique triangle is a triangle that can have either three acute angles. Acute angles means the angles that are less than 90 degrees, like the first picture. Or it can be a triangle which has two acute angles and one obtuse angle like the second picture. And we want to learn about the relationship between the side and angles of these types of triangles because we learned everything about the right triangle in previous chapters. What's the law of sine? The law of sine is a relationship between the sides and angles. And it tells us that the ratio of the length of a side of it in any triangle to the sine of the angle opposite to that side is the same for all three sides. Which means that if we find the ratio means a fraction, if we divide the length of the side A by the sine of angle A, which is the opposite to that side, this ratio should be equal to when we divide side B by the sine of angle B, and when we divide side C by sine of angle C. These three fractions, these ratios are exactly the same. And we are going to use these fractions to solve any oblique triangles. We don't necessarily need to use all three fractions at the same time. It depends on the information that's given to us. We use two of them. So in previous chapters, as I said, we learn how to solve a right triangle. When they ask us to solve a triangle, means find all the lengths of all the sides and measure all the angles, and the measure of all angles. And for the relationship between the sides in any right triangle was the Pythagorean theorem. And to find the angles, we use the sine, cosine, tangent, which the sine was the opposite over hypotenuse, cosine was the adjacent over hypotenuse, and tangent was opposite over adjacent. But remember, these properties is just the properties for the right triangle. If the triangle has a 90-degree angle, we can use them. Otherwise, we cannot use any of these properties. If we have an oblique triangle, which doesn't have any right triangle, we need to define some other properties. And usually when they ask us to solve an oblique triangle means one side or two angles, or two sides and one angle, or three sides, it's given to us and they're asking us to find other measures, other angles, or other sides. We use the law of sine when we have these two cases, SAA or ASA. SAA means the triangle that one side and two angles is given to us, and they are asking us to find the rest of the measures. Or ASA means still we have two angles on one side, but the difference is that in this case, the side is exactly between the two given angles. So SAA means we have two angles and one side. And that side, it can be any side. But ASA means we have two angles with one side, but that side is exactly between the two angles. Let's look at an example. How we can solve an SAA triangle, which means one side and two angles are given to us, and they want to solve the triangle by finding the third angle and two other sides. And it asks us to round a length of sides to the nearest 10. So what's the first step? First step is finding the third angle because it's easy. We have two angles, and finding the third angle, it's easy because we know that in every triangle, the sum of all three angles is 180. It means that the 64-degree plus 82-degree plus angle B, they add up to 180. And that helps me to find angle B because angle B must be equal to 34. So far, I found the third angle. Now I need to find the two other sides, side A and side B. And we are going to use the law of sine now. But since side C and angle C is given to us, one of the fraction that I'm going to use, it should be C over sine C. To find side A, you are going to set it equal to A over sine A, and to find sine B, you are going to set that fraction equal to B over sine B, because all the angles are given to you right now, and you just need to find the sine. So the first fraction that I'm going to use, the first is just using the law of sine for these two angles and sides. So for sure, you need to use C over sine C because side C is the only side that's given to you. If you want to find side A, you are going to use A over sine A. Now, what do? We can replace numbers, or we can simplify and find the side A first and then replace number. It doesn't matter. To find this one, the easiest way is just using cross multiplying. We can cross these two and multiply these two and multiply these two. And if I multiply A by sine C, I get A times sine C, and it should be equal to C times sine A. And since my goal is finding A, I need to divide both sides by sine C to get rid of that and isolate the A. Now you can replace numbers. You can replace 14 for C. You can replace A by 64-degree. And you can replace C by 82-degree. And you need a calculator for sure because we have no clue that what's the sine of 64-degree. So you just need to type this whole thing in a calculator and then find side A. And side A is 12.7 centimeters. And make sure that it's asking you to round to the nearest 10. It means you only need one digit after decimal points. Now, to find side B, what we can do to find side B? Again, using the law of sine. Remember, even if you have two sides, you cannot use Pythagorean theorem because that's not a right triangle. So again, you need to use the law of sine. But this time, since side C is given to me, for sure one of my fraction is C over sine C, and I'm going to find side B, so my fraction is B over sine B. And then try to find and isolate the B by cross multiplying and then isolating the B, replacing numbers. Side C is 14, angle B is 34. We found it from the beginning of the problem. And then angle C is 82, and then type this whole fraction in the calculator, and we get 7.9 for side B. Now we solve this triangle. We have all three sides and all three angles. Let's look at another example. We have a triangle, which the angle A is 48 degree, angle B is 37 degree, and side A is 100 centimeters. So when two angles are given to me, which means I can find the third angle first, because I know that the sum of all three angles in any triangle is always 180. If A is 48 degree, B is 37 degree, I can find angle C. because I know that 48 plus 37 is 85 degree, and if I subtract 180 from 85 from 180, I get that the C must be 95 degrees. So now I have a triangle which A is 48 degree, B is 37 degree, and C is 95 degree. Side A, which is the side opposite to angle A, is 100. I want to find side B and side C. How do we find them? Again, using the law of sine. This time, side A is given to me. So that means that when I'm using law of sine, for sure, I am going to use this fraction in any law of sine that I'm writing. So A over sine A is what it's given to us. So we need to use that. And if I want to find side B, I will put B over sine B first. So you don't need all three fractions at the same time. You can solve it. You have to have at most two fractions at a time. And then since I want to find B, I will do the cross multiplying. So B times sine A, which must be equal to A times sine B. To find B, I need to divide both sides by sine A. Now I have the formula to find B, and I replace numbers. A is 100. Angle B is 37 degree. Angle A is 48 degree. And if I put this one in calculator, it tells me that B must be 80.98, which if I round it to nearest 10, it's about 80 point, it's actually 81. That's side B. Now to find side C, I'm going to use the law of sine again by having this fraction first because A is the only size given to me, by sine over sine C. Again, I do the cross multiplying and isolate the C, and I will get C, it's equal to A times sine C over sine A. Now it's time to replace numbers. A is 100, angle C is 95 degree, angle A is 48 degree. And by typing this in calculator, I get 134.05, which is rounded to 1. And remember, when you're typing this in calculator, make sure that your calculator is in degree mode, because we have degree and radian in calculators, especially the scientific calculators. So you have to make sure that when you're typing these angles, since the angles are in degree, the calculator's mode is also in degree. And something else that I want to remind you, after finding side B, you may say, okay, for finding side C, can I use B over sine B? Yes, you can use that, but I always recommend you use the one that's given to you. Because most of the time, the sides that we find, it's a decimal number, and decimals are not accurate enough. So it's better to always use the side that's given to you and it's not decimal. But still, you should get the similar or same answer. Now let's see how we can solve an ASA triangle. ASA triangle means a triangle that two angles on one side is given to us, but the side is exactly between the two angles. In this example, it says the angle A is 40 degree. Angle C is 22.5 degree. And side B is 12. And as you see, side B is exactly between the two angles. Now we want to solve this triangle. So when two angles are given to you, for sure, you can find the third angle as a first step, because 40 degree plus 22.5 degree plus angle B must be equal to 180, and that helps you to find angle B. And angle B must be 117.5 degree. Now you have all three angles. Now it's time to find all three sides. One side is given to us, which is side B. We want to find side A and side C. How we do that? By using the law of sine. This time, side B is given to me, which means B over sine B is one of my fixed fraction that I'm going to use every time when I'm using law of sine. So I will have B over sine B, and if I want to find A, I will set it equal to A over sine A. To find side C, I will set it equal to C over sine C. So if I set it equal to A over sine A, isolate the A, replace numbers, I get A, side A must be equal to 8.7. To find the other side, I'm going to use this fraction again, but this time I will set it equal to C over sine C. And you will see that sine C must be equal to 5.2. So there is no difference. When two angles on one side is given to you, no matter the side is between the angles or is not between the angles, you are going to use these three steps. First step, the sum of three sides is always 180. You can use this rule to find the third angle, and then you're going to use law of sine for the two other sides. One time for the first side, and using another time for the second side. Okay. Now let's see if we have a triangle which two sides and one angle is given to us, which is called SSA. If that is the case, we call that as ambiguous case. Ambiguous case means a triangle that two sides and one angle is given to us. But when we are solving this type of triangle, we usually end up to different results. Sometimes we may end up to having only one triangle as a final answer. Sometimes we may get two triangles. Sometimes we may get no triangles at all with the information that's given to us. And you can see the pictures of different cases here. For example, consider a triangle which side A, side B, and angle A is given to you. Okay, that's angle A. If side A, which is the opposite of the angle, okay, it's greater than the other side, you will end up to one triangle, and you can find the result, and you will receive only one triangle for the result. But if side A, which is the opposite of angle A, the given angle A, it's less than side B, but is still greater than the height of the triangle. Height of the triangle means, it should be B and C. Height of the triangle means a line that we draw from one angle perpendicular to the opposite side. That's the height. But if A is greater than this height, it can be in this form over here, or it can be over here. In this case, we will have two triangles, and you can see on the picture why. If side A is exactly equal to the height, which is a right triangle, and we are going to use the properties of the right triangle. But if side A, which is the opposite of angle A, is less than the height of the triangle, we will have no triangle at all. And you can see on the picture why, because it doesn't shape any triangle. Let's get familiar with these cases in examples. For example, they ask us to solve this triangle. One angle and two sides are given to us, and they are asking to solve this triangle. I have angle A, side A, and side B. So you know that the side A, that's exactly opposite of the angle A. And if we go back to the picture, we said that if A is greater than B, we will have one triangle, but if A is less than B, we may have two triangles. And as you see here, A is less than B. So I'm guessing we may have two triangle, or if it's less than the height, we may have even no triangle. Let's see. Let's use the law of sine first. So we are going to use the law of sine because A and sine A is given to me. And I have side B. So by using these three information and using the law of sine, I can find the sine of angle B. Because law of sine tells me A over sine A, it's equal to B over sine B. If A is given to you, B is given to you, and the angle A is also given to you, that means by using law of sine, you can find sine B. And if you find sine B, that means you can use angle B. Okay, so let's do that. So if we replace numbers and try to find sine B, we get that the sine B must be 1.53 if we put that in the calculator. Now I have to use the calculator to find angle B. And to find angle B, you are going to use the sine inverse key in your calculator. And if you type this one in calculator, you don't get any answer. You may get an error. Why? Because we said that the sine and cosine of any angle is always a number between -1 to 1. There is no way that I get a sine or cosine more than 1 or less than -1. But the result that I got here for sine of angle B, it's more than 1. And it tells me that's not possible. So in this case, I have no triangle. So this is the case which we say there is no triangle. So anytime for the sine and cosine you get an answer more than 1, remember you don't have any triangle. So that's a no solution case. Let's look at another example. Okay, we have another triangle. Angle A, side A, and side B are given to us. And as you see, A is still less than B. When A is less than B, which means we may have two triangles or no triangle. We had no triangle in previous example. Let's see what happens here. So again, we're going to use law of sine to find angle B. So because A over sine A is equal to B over sine B, and if we replace A by 12, replace B by 16, replace angle A by 35 degree, we can find the sine of angle B. And the sine of angle B, it should be equal to this value. And if you use sine inverse key, because when you have a sine of an angle and you want to find the angle, you're going to use sine inverse. And if you type this in calculator, find the sine inverse of this number, you will get 50 degree for your solution. But let's look at the unit circle. Because I know that if A is less than B, I only have two cases, two triangle or no triangle. And when I have 50 degree here, it means there is a triangle. So, but it must be for sure two triangles. Why? Because if you look at the unit circle, when you get an angle 50 degree, you get the sine of an angle which is a positive number. And you know when the sine is a positive number, we always have two angles. One angle in the first quadrant, one angle in the second quadrant. Because in the first and second quadrant, both of the in these two quadrants, the sine is positive. So when you have sine b, which is a positive number here, it means you can find an answer in the first quadrant, which you got it from the calculator, and that's 50 degree. And you may also have an angle for b in the second quadrant. And how we can find that? Because we know that if this angle is 50 degree, this is also 50 degree. And since this point is 180, if you subtract 50 from 180, you get 130. So you will have two answers, one in the first quadrant, which is 50 degree, one in the second quadrant, which is 130 degree. So that's why we said if A is less than B, we may get two triangles. So far, I have two answers for angle B, which tells me I may have two different triangles, which both of them works with this information. So right now, you know angle A is 35 degree, but angle B, it can be 50 degree or it can be 130 degree. If B is 50 degree, how much is C? If B is 130 degree, how much is C? Because you know the sum of all three angles is 180. And if you add them together, set it equal to 180. If B is 50 degree, C must be 95 degree. If B is 130 degree, C must be 15 degree. So I have two triangles, one triangle, something like this, which C is 95 degree, and B is 50 degree, and A is 35 degree. And I have also another triangle, which B is 130 degree, A is 35 degree, and C is 15 degree. So I have two triangles so far. Now let's solve each of these triangles separately to find the three sides. So you know the only side you have the side A and side B. Okay, so side A is 12, side B is 16, and you only need to find side C. How do we find that? Using the law of sine again. So we can use law of sine, but this time we have both of the side A and side B, so it doesn't matter which one we use. We can use either of them with side C. So we can use side B, B over sine B, and it's better to use sine B because we have two cases for sine B. And if you want to get two different answers, it's better to use this one, because if you use A is just one, has just one solution, and you don't get two different answers. So we said B over sine B equal to C over sine C for the 50 degree angle and 95 degree angle. We again use this formula for 130 and 15 degree, and we get 5.4. And I have two triangles with this information. This is how we get two triangles, okay? Okay. How we can find an area in any oblique triangle? Because you know that we learn in high school that the area of a triangle is the half of the base times height. If I have a triangle, that's the height, that's the base. I can multiply height by the base and then divide it by 2, and it gives me the area of the triangle. If it's a right triangle, the height is exactly one side and the base is the other side, you can multiply these two and then divide it by 2. But if we have an oblique triangle, we don't know the height. And we want to use the information from the sides and angles of the triangle to find the area. And area can be found with one of these formulas. You can use this formula or use this one or use this one. Not all of them at the same time. Based on which information is given to me. If I have side B and side C and angle A, I'm going to use this first formula. If side A and B and angle C is given to me, I will use this formula. If side A and side C and angle B is given to me, I'm going to use this third formula. Okay? And to find the area, we multiply those given sides by the sine of the angle which is in between those two sides and then divided by 2. So remember, to remember the formulas, if you have B and C, you have angle A because angle A is exactly between these two sides. Angle C is exactly between these two sides, A and B. Angle B is exactly between sides A and C. Okay, let's look at an example. In example 6, we want to find the area of this oblique triangle. And in this triangle, we know that one side is 8, one side is 12, and the included angle is 135, which means the angle that's between these two sides is 135. So to use this formula for finding the area, we must have an included angle. We must have two sides and an angle between the two sides. If you see that the angle that's in between is not given to you, you need to find that first and then use the formula to find the area. Okay, and to find the area, I know that I need to multiply the sides, then multiply by the sine of this angle, and then divide it by 2. So multiply 12 by 8, and then multiply by the sine of 135 degree, and then divide it by 2, or multiply by 1/2, and you get 34 square meter. Because the lengths are, the units for the lengths are, or the sides are meters, so the area is a square meter. And to find the sine of 135, you can use calculator, or you can use the property that we learned so far about the reference angle, because I know that to find the sine of 135 degree, 135 is in the second quadrant, and the reference angle is 45 degree, which means the sine of 135, that's exactly the sine of 45. And since it's in quadrant 2 and the sine is positive, so we keep it positive, and the sine of 45 degree is root 2 over 2. Okay? But you can rewrite it in decimal if you want to multiply and see what you get. Let's look at another example, which is an application. This example says, suppose two radar stations located 20 miles apart, each detect an aircraft between them. They have two radar, okay, and they are tracking an aircraft, which is between them. Okay. And the angle of elevation measured by the first station is 35 degrees. Let me show you the picture. These are the two radar and the aircraft. The angle of elevation measured from the first station, if it's the first station, the angle of elevation is 35 degrees. And the angle of elevation measured by the second station is 15 degrees. How can we determine the altitude of the aircraft? Altitude means the height. We want to find this. So what we can do? So we have a triangle, but it's not a right triangle. Okay. This triangle, which is 15, 35, this is A, and that's 20. It's not the right triangle. And you can use law of sine to find or solve this triangle and find other sides. But our goal is finding this altitude, this side. And this side can be inside of either of these right triangles. So you can assume that you have a right triangle, which is 35 degree. This is a 90 degree, and you want to find this. But you know that's not enough information. Even if you want to use a right triangle property, you need to have one other sides. For example, you need to have the hypotenuse, this side. We also have another right triangle on this side. You can use that one as well. Find the properties of right triangle to find h, but still you need to know what's this side. You need to have one other side. So what do? We need to use this oblique triangle, use law of sine to find, for example, this side, side A or side B. Because if we have either of A and B, we can use one of those right triangles to find the altitude. So let's find A first. So to find A, I need to use law of sine. And to use law of sine, I need to have one of the fractions, C over sine C, A over sine A, and B over sine B. Since A and B, both of them are not given to you, you're not going to use both of those fractions. So let's just look at C over sine C and A over sine A. But what is the angle C? How much is this angle? If one angle is 15, other angle is 35, how much is the third angle? So if one angle is 15, the other angle is 35, we can find angle C because we know the sum of all three angles is 180. And 15 plus 35 is 50. And if I subtract 50 from 180, I would get that the C must be 130 degree. Now everything is ready to use the law of sine. And I'm going to use for finding A. So I can say A over sine A, which is sine of 35 degree. That must be equal to C, which is 20 over the sine of 130 degree. That's 1/3. And I can easily find side A from these fractions. If I do the cross multiplying, A times sine 130, that should be equal to 20 times sine 35, and then divide both sides by sine 130. And if I put this on calculator, it tells me that A must be 6.76. Okay, I have this side. It means I have this side, 6.76. So I can use this triangle, this right triangle, now to find the altitude. Because I know the properties of right triangle, and I know in every right triangle, the sine is always opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. But since in this right triangle, the opposite and hypotenuse is given to me, I'm going to use the sine formula, and I say the sine of 15 degree must be equal to opposite over hypotenuse. Again, we do the cross multiplying, h times 1, which is h. It's equal to 6.76 times the sine of 15 degree. And if I type this in calculator, I will find h, which is 3.88. Oh, I think I made a mistake here. Let me fix that. This is not 6.76, it's actually 14.98. That's 14.98. That's 14.98. And this side is 14.98. Yes. If you type it in calculator, you will see that the answer must be 14.98. So for solving this application, I'm going to use the law of sine to solve the oblique triangle, and then using the properties of the right triangle.